Good morning. Good morning, everyone. Thank you for being here at our conference. And thank you, Sarah, for your kind introduction. Yes, it's true, our meetings sometimes are passionate, let's say. So today I'm going to talk about the work we're doing at ERA to build a solid software capable of supporting the complex environmental and compliance issues that my fellow speakers talked about. My presentation is all about software architecture and development, and when I was asked by Sarah to talk about it at an environmental conference, I was a bit reluctant, but then I realized, I'm sorry, But then I realized that in order to build that trust between us and our clients and business partners, it's important to have this open dialogue about the software development efforts and be transparent about it. So, with this in mind, this is the outline of my presentation. I'm going to do a bit of a review of our dynamic platform to understand where we started and the reasons we push for a new software architecture. I'm going to talk about the traditional architecture, the one that's supporting the ERA software from the beginning. 14 years ago when I started, we developed using the traditional architecture. The new one, the one that's going to help us move into the future. And we are designing the new architecture following the domain-driven design 100%. Also, I'm going to talk a bit about the test-driven development, which is a nice complement to the domain-driven development. It's helping to build a solid, bug-free software. In conclusion, I'm going to talk about the future, where we're going, and where our platform is headed. So when I started 14 years ago, and we started developing the first version of the web application, we moved Regment to the web. The design was a classic one. It was an application embedding the scientific body of knowledge, environmental EH&S compliance, into a specific technology, ASP.NET SQL Server in our case, and into a fixed system application and the behavior. All the clients will see the same pages for emission, waste, water, training, and so on. This is good when you develop a software, you sell it, and be done with it. It's not as good when you're trying to develop a sustainable software as a service solution on the long run. As the solution grows in complexity, the problems grow bigger. Such problems are mostly the difficulty to change the technology. You guys know technology is advancing rapidly, and every time Microsoft would release a new version of a .NET framework or a SQL Server, we have to test, to go back and review if it doesn't break the business logic and affecting our clients. Also, it's difficult to support all the different client needs. Everybody wants the form and the flows their way, a button here, a text box here, a red button there. So with this in mind, in 2014, so 3 years and a half now, we tried to address the need of the client. We needed a dynamic platform which would be scalable, flexible, easy to use, that connects people, data, and decisions. Also, we needed to be able to build the forms per client requirement, and if necessary, if it's a bigger process, to link them in such complex business processes. Also, we needed to provide tools that would build strong logic between these forms. And in the end, and this is Gabriel's area of expertise, to extract the data that we put into the system into dynamic, flexible reports. So the traditional layer architecture is the one that we had initially. It's a good one. It's a robust, it's a strong architecture widely used in today's application. It's taught in university. A lot of people are using it. It has some drawbacks once the solution grows in complexity. And the main drawbacks are that each layer depends on the one beneath it. Every layer will depend on a common infrastructure, and the big drawback is the coupling that it creates. This makes update difficult, if not impossible. So these drawbacks stopped us to further develop the system with issues in both maintenance and of current software and new development. So we needed to go back to the drawing board and find something else, a new, modern, advanced, scalable architecture. We realized with the first version of the dynamic platform that we need to separate the scientific knowledge, the domain, scientific knowledge, the environmental compliance, health and safety knowledge, from the dynamic force, which needs to act as mere of an interface between the user and the domain, and also to separate the scientific knowledge from the technology, whatever we have in the back end, SQL Server or any other technology, .NET or whatever else is going to be available in the future. In the end, we're going to have a card with business components, scientific knowledge, and a card with system components, forms, pages, data types. For each client, we're going to be able to create a customizable system. Sorry. Customizable system using the two cards. Also, the technology in the back end for us is going to be easier to update as soon as new versions appear or new technology appears without disrupting the software. So from the development perspective, from our perspective as the developers, we need to have easy to understand pieces of software. We hired a lot of new developers, and even for the senior ones, they need to go quickly and understand what's happening inside. Easy to test and to debug. Easy and fast to extend and to add new features. From the user point of view, it needs to be easy to use, fast, and of course with a minimal amount of bugs and never recurrent ones. So this is our winner. We went back and we studied, and it's the onion architecture, and the name comes from its layers. The main advantage of the onion architecture is that it controls coupling. All code depends on the layer more central, but code cannot depend on layer above. It's a fully object-oriented programming model. At the center, domain model, it's only coupled to itself. The database is external and it's not the center. If you look at the flattened diagram, you can see compared to the traditional architecture, the data access, it's on top. The object, where the main code is written, never depends on the other layers. So for us, this is our implementation. Our BPM or dynamic core, it's in the center. We have our interfaces on top, which will relate to any interface, web forms, MVC, mobile, to other services, to other systems, to the database, SQL Server in our case, and to the test. And I'm going to talk a bit about the test in a later slide. So all the dependencies are towards the domain model in the center. To make an analogy, the core would be the constitution of the ERA-EHS system. It's our truth where we define the main pieces of our software. And like in real life, the constitution doesn't change. We just bring amendments, which is what the implementation of the interfaces represent. This is a flattened representation. As you can see, the database and the infrastructure stuff, it's in external. In the center, we have the application flow, the domain workflow, and the modules of the ERA application are plugged in using business logic, all the environmental, wastewater, and compliance training modules. On top, the UI, mobile, web, or any other type, as well as external systems, will connect using web APIs mainly. Of course, we can support. We're going to support any other type of data transfer using XML or CSV and Excel. Well, to write such a constitution, we went and back and we decided to use the domain-driven design. Okay. The domain-driven design. It's a strong, solid design, fully object-oriented. Domain models, the domain model is in the center. You see here a bunch of classes. It's very small because it's big. It's actually bigger. I took a smaller slide out of it. But the important thing here is that the domain model in the center, that's like the constitution. The model resolution to any database model and any changes will be done in the model resolution. Also, the relation with the workflow, it's done through interfaces. Any changes brought to the external workflow or model resolution will not impact the domain model. In the domain model, what we have there is the letters of the alphabet, the questions, the answers, the form, the step, and in the end, the process. So now I'm going to switch to test-driven development, which is a natural complement of the domain-driven design. It's a quality assurance methodology, and it helps eliminate the bugs. So what's happening, actually, the requirements for a new piece of functional code are written as test. Then the code is written to pass that test, hence the requirement. As a simple sample, if, let's say, you need to write code to implement the addition. First, you write a test that will assert that 1 + 1 is 2. At the beginning, of course, the test will fail because there's no code to implement 1 + 1. You write the code, and then, of course, the test passes. Then in the future, if somebody goes in within the same method to refactor the code, to change it in to make it better, of course, this is a simple example, but in our case, it's very complicated. If anything is done and it's wrong, the test will fail. So the programmer immediately will see, oh, I did something wrong. Actually, Visual Studio from Microsoft helps us. It won't allow the programmer to check in that code until all the tests are being passed. You can write thousands of tests for any piece for all the pieces of code in the application. All of them run in milliseconds, and it assures that there are no bugs when you check in the code into the source code. This helps minimizing the bugs in the system. It adds an overhead in the initial development. Of course, it's a bit extra code to write, but well worth it on the long run. So finally, I'm going to talk about what the future holds. So we started in 2014 with our first version of the dynamic platform, following kind of the same architecture that we had initially, with technology, the dynamic application, and scientific knowledge coupled together. Our goal, which already started working on it, and we're moving slowly into the production application, is to have the 3 levels evolving independently. The scientific knowledge, it's continuously evolving, of course, with new regulations and new requirements for the clients. Our dynamic application that we built to support the scientific knowledge will, of course, offer new features. And whatever technology will be available in the future in the back end, we're going to be able to change that without disrupting the main application and the clients. And I'm at the end of my presentation. Before questions and thanking you for listening. I want to take advantage of this opportunity and thank my team. They are great. Without their dedication and hard work, we wouldn't be able to do all this. Andre, Gabriel, and Tin is here also from my team, the timekeeper. Yash is here, and Kawal. Also, the other guys at home that are helping us to build this software. Thank you.